Okay, we're going to find the limit, and we're going to prove this using, or find delta such that we are using the epsilon delta definition. First off, we're going to find the limit of this one. And what we have is another continuous function. So when you find the limits of a continuous function, we can use what's called direct substitution. So we're going to take the c value that we're given here, and we're going to plug it into our function. So we have 2 squared minus 3, and that's going to equal 1. Okay, so we have a limit of 1. Okay, I know, hopefully understand that limits are actually when we have our function right here. We are going to be taking this, we're going to go down 1, 2, 3. And as we approach this right here at 2, we have this value of 1. But as this is going through, okay, we have our graph, and we are approaching, all right, 2 here. And as this gets closer and closer to, from either side of 2, it appears that we're approaching 1 because it's continuous. The limit is going to equal the actual value of the function that we have right here. Now, what we're going to do is we're going to try to find out, using epsilon delta definition, of what would be a delta x, which has to be greater than 0, all right, that will satisfy our epsilon of being 0.01 units away from our limit. Okay, so essentially we're looking for, all right, a delta. So if you think about this, that we're going to have a 1.01 units away, all right, from right here, and then we have another one, which is going to be 0.99, all right, units away for other value. And where is that going to be? So how far do we have to be from 2, all right, our input, in order to guarantee that we are only 0.01 units away from our limit, which we have there. Now to do this, we're going to set this up. We're going to take our function, x squared minus 3. So just plug everything into our epsilon delta, all right, definition here, minus our limit, which is 1. This has to be less than 0.01. All right, remember this is epsilon. And now we have over here our delta, which we know is x minus our c value, which is 2, which is less than delta. Okay, now solving this, we're going to go through, and we're going to simply simplify this side so it looks like this inequality, and that will help us determine what delta was going to be. To do this, we're going to simplify this by saying x squared minus 4. Okay, and we have 0.01. Now there's many different ways of doing this. All right, I'm going to show you one method, and in which we're just going to solve for x. So if we take this x1, we're going to add, we're going to change this into our inequality, negative 0.01. And we're going to add 4 to both sides, so we have 4.01 squared. We're going to add 4 to this negative, so we have 3.99. Okay. Now from here, what we're going to do is we're going to solve for x by taking the square root. So we're going to take the square root of 0.401 x, and then we have right over here the square root of 3.99, and we have that. Now, to figure this out, all right, and to finalize this, is that we need an inequality like so. So what we're going to do is that we're going to subtract 2 from both sides. Subtract 2, subtract 2, subtract 2. And so we're going to determine what these values are by going and taking our calculator. So I'm going to give a second, pause this, and come back and give you my calculator ready. All right, and we're back, and as you can see, my calculator just happened to pop up. But as we see this right here, and we find these values, you can see that I plunged into my calculator square root of 3.99 minus 2, and we have negative 0.0025. I'll just take that one. And then on the other side, you can see that when we did that, we can 0.0025 we round, and they happen to be the same value. Because they are the same value, let me just minimize this, we can then rewrite this as an absolute value of x minus 2, which is less than 0.0025. Oops, okay, 25. And we realize that x minus 2 and this are the same, so epsilon would have to equal 0.0025, and therefore any values as we plug this in here, that when you get closer to c and you're at 0.0025 or less than that, would give you a limit guaranteed to be less than 0.01 on both sides of the limit. That is another example of how to use the epsilon delta definition to find out a value, a delta, all right, that will guarantee you an epsilon of a given mark. All right, so this can help you identify how to find delta given an epsilon and using the epsilon delta definition of finding limits. Good luck and God bless the rest of your problems.